And we were trying to get CUDA to be a good computer vision processor. And we were frustrated by a whole bunch of early developments internally with respect to our computer vision effort and getting CUDA to be able to do it. And all of a sudden, we saw AlexNet, this new algorithm that is completely different than computer vision algorithms before it, take a giant leap in terms of capability for computer vision. And when we saw that, it was partly out of interest, but partly because we were struggling with something ourselves. And so we were highly interested to want to see it work. And so when we looked at AlexNet, we were inspired by that. But the big breakthrough, I would say, is when we saw AlexNet, we asked ourselves, how far can AlexNet go? If it can do this with computer vision, how far can it go? And if it could go to the limits of what we think it could go, the type of problems it could solve, what would it mean for the computer industry, and what would it mean for the computer architecture? And we rightfully reasoned that if machine learning, if deep learning architecture can scale, the vast majority of machine learning problems could be represented with deep neural networks. And the type of problems we could solve with machine learning is so vast that it has the potential of reshaping the computer industry altogether, and which prompted us to re-engineer the entire computing stack, which is where DGX came from, and this little baby DGX sitting here. All of this came from that observation that we ought to reinvent the entire computing stack layer by layer by layer.